So the top of this is what we had before, yes? So 180, how did we do it yesterday? Square root of 180, what'd we do?
4. You definitely need a 4.
You added them up to see what could go in.
Multiply them. Okay, there's a perfect square in 180. What is it?
9.
9. 9 times 20, yes? Okay, is a perfect square in 20?
No.
No. 4.
4. I have 4 and 5, don't I? So I have the square root of all of these, correct? I'm going to try this differently because some issues I had, people were like, weird issues. Okay, what is this? I can do pairs or square roots, right? Okay, what is the square root of 9? 3. So I can bring out a 3. When I mean bring out, I took the square root of it, right? It's done. Please don't tip on the chairs. Okay, what's the square root of 4? 2. So it can come out. Can 5 come out? No. So it's just the square root of 5, isn't it? And 3 times 2 is 6. So I have 6 square root of 5. So that's what we did yesterday. So today we're going to add in, look at number 3. We're going to add in a variable, yes?
I knew this was
Same thing. We're looking for pairs of what? 2. Yes? Okay, so 48, what's the perfect square in 48?
4.
4 goes in 48. 4 times 12. Is there a perfect square in 12?
Yes.
4. So I have 4 times 4 times 3. Yes? And if I have x squared, how many x's do I have? X times x. Is that correct? So, if you guys would have known that 16 times 3 was 48, you could have gone faster. But you'll get there. Okay.
I did.
I can bring out a pair of what?
4.
And I can bring out a pair of what?
X's.
X's. So it's 4x square root of what? 3. Now I could have took the square root of 4 and the square root of 4 and taken 2 times 2 and got 4, but I just brought both 4's out, correct?
So you took x times x to get it?
Well, x times x is x squared, yes?
Yeah.
So I just wrote them out so you could see them
How did you get 4x?
because I have a set of 4's.
So then you could have an answer just as like. She multiplied the x and the 4.
Yeah.
That's what she did.
4x is just 4 times x. Okay, now I'm going to show you an easier way to do this, but I wanted to visually. Since we're looking for the squared root, if we divide the exponent by 2, what's 2 divided by 2? 1. So I can bring out 1x. See that? If I have the square root of x to the 5th, I divide 5 by 2. How many times does 2 go into 5?
2.5.
Twice. Twice full. And 1 left over. Because if I wrote this out, x to the 5th would be x, 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 x. Yes? How many pairs of x's do I have? 2. Hence the 2. And what do I have left? 1. So if that was the cube root, I'd divide it by 3. If it was the 6th root, I would divide it by 6. Do you get how that works? You want to do another one?
Yeah.
Okay. The square root of x to the 8th y cubed. So we're going to divide by what? 2, because it's a square root, right? How many times does 2 go into 8? 4. So I can bring it all out. There's no left over, is there? Now the y. How many times does 2 go into 3?
Once.
Once, and there's what left over? 1. So I'm going to write it all out so you can see it.
So pairs go on the outside.
Yes, just like the
non-even
square.
ones go on the inside.
Yep. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. If I wrote them all out, yes? I've got 1, 2, 3, 4 pairs.
Mm-hmm.
So x to the fourth, because x times x times x times x would be x to the fourth, right? And 1 pair of y's. And what's left over? 1 y. Make sense? Now, you could write it all out like that if you'd like. Or you could just divide it. So let's look at 5. So the negative 2 does nothing. It's just out there, right? When I get my answer, I multiply it times whatever I get out. So 80, perfect square and 80.
7
Okay, perfect square and 80.
8.
Perfect square and 80.
4.
4. Yes? I'm not asking for hard numbers, guys. At least 4.
4 and 20.
4 and 20. Is there a perfect square in 20?
Yes, 4.
4. So I have 4 and 5. So I have 4 times 4 times 5 and x cubed. So I'm going to have negative 2 times what? What could I bring out?
4.
I can bring out a 4. And then I divide the 3 by 2. How many times does 2 go into 3? Once, with how much left over? 1. So we're going to have 5x left in, right? Because I had 1 left over. And negative 2 times 4 is?
Negative 8x.
So negative 8x, square root of 5x. If you need to write all of them out like I did over here, then do it. You only have 4 problems to do. Got it? What's in front of the 7 radical?
Negative.
A negative 1, right? So don't forget the negative. Okay, number 9. We're going to jump around and do problems, and you guys should get approximately 20 minutes to work on your own. That's what last hour did. Again, same rules apply, that when you're working, and if you're not working during work time, I pick up at the end of class. Okay, so before we get started, I want to talk to you about if I have 2x plus 3x plus x squared. Okay, what can I add?
That's 2 and 3.
I can add these two because they're like terms, correct? And I would have 5x plus x squared, which I should have x squared plus 5x, right? And it's the same with subtraction. They have to be like terms, don't they? Okay? So since they're not alike, I can't add the x squared, or if that was a y squared or whatever, it has to be exactly alike. So with radicals, the same thing applies. They have to be the same root. So if it's cube root, it has to be cube root. And the stuff inside is called the radicand. Nice word, right? Has to be exactly the same. So what I have on 9 is I have 1 square root of 2. And I have 1 square root of 2. So how many square roots of 2 do I have? 2. So I have 2 square roots of 2. Just like if I had x plus x, how many x's do I have? 2 x's. Make sense?
So what'd you do all that work up there?
I was showing you. I was showing the same. You know that concept.
So is 2 square root of 2 the answer?
Yes. That's the answer.
Okay.
Okay, so the next one. I have 3 square root of 6 minus 3 square root of 6. Don't say the answer out loud. Do it. Would anyone like to share their answer? It's really easy. Yes.
Would it just be 0?
It would be 0. Why?
Because they're like terms.
Well, yeah. I have positive 3 and I have negative 3. So I have 0 square roots of 6, which is just what?
0.
0. It's exactly like variables.
So on number 9, if the addition sign would have been subtraction, that would have been 0.
Yes. Okay, 11. What's my problem with 11?
They're not like.
No, not the same. But is 54 simplified?
No.
Nope. So guess what I have to do first?
Simplify.
Simplify it. Okay, so perfect square in 54.
9.
Okay, so 9 times 6, yes? So the square root of 6 plus, what's the square root of 9?
3.
So 3 square root of 6. So now are they the same radican? Are they alike now?
No. Well,
Yeah.
yeah.
Yes. So how many square roots of 6 do I have?
12. Right?
4 square.
4 square root of 6.
Oh.
There's the one in front of the first one.
Okay, there's a 1 in front of here. And what is 1 plus 3?
4.
4.
That is.
I have 4 square roots of 6.
So you can't. So yeah. So
You're
you
not,
can't
it's just like,
words.
yeah, it's just like x's. When I add x's, I have 2 x's, correct?
Yeah.
Okay, I have 4 square roots of 6.
Alright.
Okay, let me show you here. I have a square root of 6 plus square root of 6, square root of 6, square root of 6. How many square roots of 6 do I have up there?
4.
4. Make sense now? Don't do it like that ever. That would take you forever and a day. Okay, so on 12, what do we have to do first?
Simplify.
Simplify. So do it. Henry.
I got it. Thank God I don't know what I'm doing.
Simplify them. We did yesterday.
I still didn't get what we did.
Okay, Henry, what's the perfect square in 45? 9 and 5. So write 9 and 5 under there. Okay. What's the perfect square in 20?
4 and 5.
So 4 and 5. Okay, so remember there's a square root over both of them, right? What's the square root of 9?
3.
3. And the square root of 5 stays in there, correct? What's the square root of 4?
2.
So I have 2 square root of 5. So they're like, are they alike, Henry?
No.
I have square root of 5 and square root of 5. Are they alike?
What about, no.
It doesn't matter. Are the square roots the same?
Yes.
Okay, so how many square roots of 5 do I have? I have 3
5.
and I have 2. I have 5 square root of 5s. Did you guys get 5 square roots of 5s?
So you always break it down as far as you can first?
Yes. Now, could I possibly get down to an answer? Let's say, this is an example, guys, nothing to do with that. I get 4 square root of 10 plus 5. Actually, we'll do a minus. Doesn't matter, right? Minus square root of 15. Okay, I simplified it. That's what I got. Can I do anything?
No.
No. That is my answer then.
Fine.
Make sense? If these radicals are not the same, then the whole thing is your answer.
Okay.
Do we need to do one more?
Yeah.
How about 18? Oh, look at 19 and 20. There's 3 of them. Does it matter?
No.
No. They just, you do it all. Okay, 18. Try it on your own.
Is 13 4 square root of 3?
Is what?
14 square root of 4.
For what number?
13.
Yes.
Let's go.
Okay, 18. Make sure you're getting them right.
can go into 18 too.
2 and 9.
I got 2 and 9, but I got 2 and 4 for the next one.
So I'd have to add the
Mm-hmm.
other 3 to this 3 with the 18.
No, they're 2 individual problems until they're all simplified. You do nothing because you have 9 and 2, yes?
Yes.
And you have 4 and 2. So what's the square root of 9?
3.
3. So 3 times 3 is 9. Square root of 2. What's the square root of 4?
2.
So you have 3 times 2, which is 6, square root of 2. They are 2 separate problems until they're all simplified.
So if there's a number in front of it, you always have to like multiply first?
Yes.
One question.
Yes.
Why do you do it times the 4?
Because you have to take the square root of it. Because there's a square root around that.
It's just hard to set up.
So then you multiply it by 3.
That's
Mhm.
the reason.
So 3 times 3 is 9.
I'm stuck.
I just looked at the board.
What? What, Henry?
Where are we multiplying the 3 by?
Okay, you have a 3 already. The square root of 9 is 3. So 3 times 3 is
9.
9. Square root of 2. And the next one, what's the square root of 4?
2.
2. So bring the 2 and multiply it times this 3. So 2 times 3 is 6. Square root of 2. So now you can put them together, and 9 plus 6 is 15. Okay. Now when I go down to 21, 22, is that exactly, that was on the bottom of your worksheet yesterday, wasn't it? Yep. So those are all the same. I would suggest, guys, look on 24. If you don't look carefully, you don't see the multiplication, you see the what? Subtraction. You know what I would do with all mine? Put parentheses, because it will help you. Okay.
If there's multiplication and subtraction, is it just like a negative 2? Like the square root of 2? Or
Well, no, this is just all multiplication,
what's the minus symbol?
because there's a negative 1 in front.
That's what I was asking.
So it would be negative the square root of 12, which would be 4 and 3. So it'd be negative 2 square root of 3. That's it. That's why I said put the parentheses there so you don't try to subtract. Okay, on the back, anything look different? Put your parentheses on 25 and 26. Oh, do we need to do 25 or 26?
No, I'd rather.
What do you think you do with like the negative 4 and the 6 and the 2 on 26? Negative 4 and the 2. What do you do with those two numbers?
You can multiply.
You multiply them. You multiply the outside, you multiply the insides, right? Same thing as you're doing. Okay, what about 27 through 32? Do they look different?
I'll read you guys.
We have to distribute, don't we? So let's do 27. So the square root of 6 times the square root of 2 is the square root of what? 12. Plus the square root of 60. And now I have to simplify them to see if I can add them.
4 and 3.
So we got 4 and 3 here, yes? So the square root of 4 is? Right, am I writing too small?
2 and 2.
Okay, so 2 square root of 3. Okay, 60.
4.
4 and what?
Well, no.
15?
Yeah, 15.
Square root of 4 is? 2. Square root of 15. Now, can I do anything in there?
Yes. Can't you get 15 to.
No. We're adding. Can we add those two things?
No.
Why?
Because the square roots are the same.
The radicans are not the same. You're done. If you can add them, add them. If you can't, you're done.
So we just put no's.
No, that's your answer.
Oh,
There's not a no.
128 does it have to do anything with 5 not being a square root?
No, it does not. You just multiply. Okay, so you multiply whole number times whole number, square root times square root. Okay, so there's a 1 in front of the square root, correct?
Yeah.
Okay, so 1 times 5 is what?
5.
So we're going to have 5 square root of 3 plus square root of 30. Is there a perfect square in 30?
3.
No, 3 is not a perfect square. 30 is 5 times 6.
That is-
There's nothing, is there? So that's it. You're done. Do we need to, you guys want to do one more? Which one do you want to do? And then you'll check it before you go on your own.
32.
30 what?
2.
Okay, so do 32. We'll check it before you go on your own. Now remember, this is due before class tomorrow. So as soon as you're done with it at home, please turn it in.
Wait, what's 21 times
63. Because what's 1 times 3 and 2 times 3?
I don't think you can do it.
Yes, you can.
What is
What's the perfect square?
What?
What's the perfect square?
3 got?
3 times 3 is 9. 9's a perfect square. 4, 9, 25, 16, 36, 49.
Nine can go in the system.
All the ones on your squares and cube sheet.
7 times?
The answers are perfect squares.
I think I left that at home.
Well, you got to know it anyway. You guys got a quiz sometime this week.
Yeah.
What's that?
Okay, did you get 35 square root of 3 minus 30 square root of 7?
No.
Why not?
Is that something different?
Jake,
Did you mix them?
Oh, wait a second. I forgot my other 7.
what do you think? 3 times 10.
No. I did this one wrong. I put that 7 in the square root. Is that 7 in the square root? No. There you go.
I had the first part.
Yeah, I got minus 10 to the square root of 63. Because I just multiplied 5.
Yeah, but 63 is 9 times 7. You have to simplify 63.
And where did the 9 go?
Okay,
Oh, you
so,
simplified it down and multiplied it by the 10.
right.
30.
See,
Right.
do you notice what I did? I didn't multiply it out. Why didn't I multiply it out?
'Cause you-
Because I was going to have to break it down anyway, right? So I did 21 and 3 in that. But if you did 63, you would have done 9 and 7.
And then got
The square root of 9 is
3.
3, so 3 times 10 would be 30. So
Alright.
you got to keep going. Keep going until there's no perfect squares in there, okay? So you have the remainder of the time to work. And it's 16 minutes. I don't know why we didn't have 20. Maybe we didn't have 20 before. So work. If you get it done, if you want to check your answers, you can come up and check your answers as you go.